All right, now we're on the 3.2 set, and we're finding arithmetic and geometric means where it starts out with just a straight up Math 1 review. So the top section here, just finding the arithmetic mean and the geometric mean of these first 6 problems, this is from Math 1. And you will need a calculator to be able to take cubed roots or fifth roots of things. Then when we get down here to this section, this is the Math 2 connection of the in-betweeners. So here we go with the Math 1 content arithmetic means. They're first asking us for an arithmetic to find the common difference and then to fill in the table. So we write out an explicit based on the bottom of this table right here, where we say this is a function that begins at 5, is adding some number 1, 2 times this common difference. I don't know what it is, and that should end up with 11. Just using the bottom of this table, I write out that equation and solve it. So I'm minusing 5. 2 times that common difference is 6. So my common difference is 3. Now this one is so simple, you might have been able to do that one on your own. 5 plus 3 is 8. 8 plus 3 is 11. But then the numbers get bigger or they're subtracting, and so it's good to know how to do that formula because you can apply it to these bigger problems. So here I go. This is a function that begins at 18. Actually, let me write this over here to the side. Begins at 18 and is adding 1, 2, 3, 4 times. And that's going to end up at negative 10. So then we subtract 18 from both sides. I get 4d equals negative 28. So I get the common difference is negative 7. Why is it negative? Because we're subtracting every time that number is going down. So that makes sense. So here I go minusing 7. What's 18 minus 7? What's 11 minus 7? What's 4 minus 7? And what's negative 3 minus 7? And that does land on negative 10. Feel free to use a calculator to double check that if you're not sure. All right, next one starts with 12. Adding 1, 2, 3, 4, 5, 6 times some unknown number, and that should end with negative 6. I get 6d equals negative 18. So I get my common difference is a negative 3. Again, it's a subtraction. So if I'm minusing 3, I get 9. Minus 3 is 6. Minus 3 is 3. Minus 3 is 0. Minus 3 is negative 3. And then that works again for the negative 6. So all these little side blue equations are how you create an equation from the bottom of the table to do your arithmetic mean. Now for the geometric mean, it's a very similar formula. I'm going to do this one in purple, except instead of a common difference being added repeatedly, we now have a common factor for the geometric. So it begins with 3. 1, 2 jumps means this time we're going to have a factor of r twice. R times r is r squared. So instead of plusing 2d, we're r squaring it. That ends up with 12. So we get r squared equals 4. We square root both sides. We know that our common ratio is 2. So 3 times 2 is 6. 6 times 2 is 12. There it is. Okay, well, now the numbers get bigger, so hopefully you are comfortable with that equation. We go begins with 7. 1, 2, 3 times, so that's r to the third equals 875. Grab a calculator this time. Do 875 divided by 7. I got 125. Now we cube root both sides. And so if I grab my calculator and I do 3 second anything root, 125, the cubed root of 125 is 5. So 7 times 5, 35 times 5. And then 175 times 5 gives me 875, so that checks out. All right, pause the video and try the last one on your own if you haven't already. And let's see how you did. This one begins with 4, with 1, 2, 3, 4, 5, r to the 5th power factors. Equals 972. We divide by 4. We get that r to the 5th equals 243, and we have to take the fifth root of both of those. So 243, 5, second, anything root, 243, enter, is 3. So my multiplier is a 3 this time. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. And 324 times 3, we always check that last one to make sure it gives us the 972. Okay, so far we just did Math 1 content. You're supposed to know how to do those from last year from Math 1. How's that going for you? Now we're jumping into the Math 2 where we have the in-betweeners in between those big jumps. So notice that from here to here, from 4 to 16, we notice that the big jump 4 times 16 would be 4. So they're calling this factor W, f of W. So we would say that big jump is 4. So 16 times 4, the big jump is going to be 64. So f of W is 4. Now there's some little jumps in between. We're splitting that 4 up into 2 smaller jumps. So if I use the formula that we just applied above, I would write begins at 4 with 1, 2 little jumps, r squared equals 16. R squared is 4. Square root both sides, r is 2. So the little jump is just a 2. So 4 times 2 is 8. 16 times 2 is 32, etc. So no weird square roots yet on our in-betweeners. It's just showing that a big jump of 4, because that's a perfect square, when I square root it, it makes little jump of 2. So it's times 2 on the interior. Okay, so 16 is done. Let's go try 17, same concept. What's the big jump going to be this time? Well, from here to here, 4 times what makes 8? Okay, well that's just 2. And then 8 times 2 is just 16. So our big jump FW is 2 times 2. That's our factor. Now we're going to break that up into a little jump. So we say 4 r squared equals 8. So r squared equals 2. When I square root both sides, this time I get that my little jump is root 2, root 2. My FC is root 2. So 4 root 2, 8 root 2 would fill in that table. Pause the video, try the next one on your own. Okay, let's see how you did. Big jump right here from a 5 to a 15. Do you see it? You got it. That's just 3. So 15 times 3 would be 45. Then we're going to break up that jump of 3 into 2 smaller jumps, right here and right here. 5r squared is 15. So r squared is 3. Break that up into 2 jumps. R is root 3. So 5 root 3, 15 root 3 fills in the table. Okay, how are you doing on those in-betweeners? I'm not assigning the go tonight. We're stopping there.